All right, folks, it's Bass Action back in action here. In this video, we're going to cover three major topics. We're going to look at exponent rules, writing equations of lines, and then also just a refresher on solving equations by clearing fractions. It's important to note that as we're working through these problems, you should not need a calculator, nor should you use a calculator on any of these. So get in the habit of working without a calculator, because on many of our assessments, including the AP exam, you will not have a calculator. All right, jumping into our exponent review here, we're going to take a look at our first problem here. And there are some things that you can just mark on the problem and kind of keep track. And then sometimes we'll need to do a little middle work along the way. So first thing we want to notice is that the 5 and the 30 could just reduce. Those are simply coefficients. That's going to leave us with a 6 in the denominator. The x's are also pretty easy to work out. We've got 5 in the numerator, 3 in the denominator. We're going to subtract those exponents. So that would cancel and leave us with an x squared in the numerator. And then we have this y to the negative 2. This negative exponent is going to move the entire thing to the denominator, making the exponent positive. That's going to leave us with a y and a y squared in the denominator. So when we get to our final answer, that's going to give us a y cubed there. So we can fill in the remaining pieces we already calculated, and that would be our final answer. Now, this next one has a little bit more going on, and there's some important details here. First thing, this negative 2 squared, this negative in the front is not attached to this exponent of 2. So what you might want to do is take that negative, I'm going to flip that to a positive, and I'm just going to move that negative to the top right off the bat. Now, 2 squared is 4. That will reduce with this negative 8. Then we can mark this whole thing out and mark this piece out and rewrite it as a negative 4. On our x's, we've got this exponent of negative 2, and here we have a negative 1. It might be a little easier to do a little middle step rewrite here. So I'm going to rewrite that negative 4. I'm going to move the x to the negative 2 to the denominator. I'm going to keep the x to the 4th. Sometimes I even like to mark them off as I go along to make sure I don't forget something. This entire quantity to the negative 1 is going to move to the denominator. So I'm going to have a y and a z. I like to cross my z's. And then I need to keep track of that y right there. Now I've got everything moved with positive exponents, and it's easier to do the final collecting. So I have a negative 4 in the numerator. I'm going to collect my x's. That'll become x to the 6th. I'm going to collect my y's. That will become y squared. And then I just have the 1z that is left. Next thing we're going to take a look at are the rational exponent problems. And the trick on the rational exponent problems is to look at the denominator of each of these exponents. Now, what we want to do is we want to look at this base and ask ourselves, can we rewrite 4 with an exponent of 2? And we can. 4 is 2 squared, and then I rewrite the exponent, and now we can recall that these two exponents would multiply. So this 2 and this 2 cancel, and we're left with 2 cubed, or in other words, 8. We can do the same thing over here. Can I rewrite 27 with something to the 3rd power and 8 with something to the 3rd power? I can. That's going to become 3 cubed and 2 cubed, and this whole thing is to the 2/3. And now this exponent would distribute, so now these 3's cancel, all the 3's are gone, so we have 3 squared. That's going to give us 9, and we have 2 squared, which gives us 4. So we're all done there. Next thing that we're going to look at is equations for lines. The one that we're going to use the very most in this class is point-slope form, and I've given you that point-slope form right here. This is going to be our big focus in this class. The nice thing about point-slope form is it also gives us the equation for slope. Our m is slope, so if we solve for that by dividing both sides of this equation by this x minus x sub 1, we will get that our slope is equal to y minus y sub 1 over x minus x sub 1. In the past, you probably also thought of that as a rise over run. And now we're going to add in this triangle and a y and a triangle and an x. And what this means, this triangle is the Greek letter delta. And now this reads the change in y divided by the change in x. So the change in y is that difference. The change in x is the difference. So now let's look at an example that puts all this together. If we want to write the equation in point slope form for a line that's going to go through this point will become our xy pair, and that's what we'll substitute here and here. We want our line to be perpendicular to a line that goes through these 2 points. So we first need to know what is the slope of the line that we're starting with. So we're going to calculate our slope. So the numerator is the change in y, so y minus, or 4 minus a negative 1, so 4 plus 1, negative 7 minus 6, so negative 7 minus 6, that gives us 5 over a negative 13. Now that's the slope of this line. We want ours to be perpendicular. So ours is going to be the perpendicular slope, which is the opposite reciprocal, so 13 over 5. Let's put it all together. We've got our point and our slope, and we're going to substitute. So now we're going to have, slide this up. So now we're going to have y minus a negative 3, so y plus 3. Then we'll have our slope, and x minus a negative 26, or x plus 26. Now, this is a perfect example of one that if you're not reading the directions and knowing that it needs to be in point slope form, and you try to take this to slope intercept form without a calculator, this is going to get really messy really fast. So not having a calculator doesn't make the problem harder. It actually is kind of a hint and tells you that you're probably going to leave it in a really friendly form. The other kinds of lines we want to look at are the vertical and horizontal lines, and that's what this next section is going to look at, is our vertical and horizontal lines. Students often struggle with these. So the first thing that we want to think about is what is the slope of a line that is the equation x equals 7. So if we visualize what this looks like, a line that is the equation x equals 7 means that every point on the line has an x value that is equal to 7, which means our line has to be this vertical line right here. So the slope of a vertical line has to be the word undefined. We don't want to say none or no slope. We specifically say that the slope is undefined. Now, if we want to know what is the slope of a line that is perpendicular to this line, well, a line that's going to be perpendicular is now going to be a horizontal line, and the horizontal line is going to have a slope that is 0. Again, we don't say no slope, we specifically say 0. Now, if we want to write some equations of lines, let's say I want to write the equation of a line that's going to be parallel to this one, that's the x equals 7, and is going to go through this point. Well, if it's parallel, it's another vertical line, so another vertical line is going to be x equals. From there, we can just use the x value, so x equals negative 45. Now, sometimes that messes students up and that feels like a lot. And if that's the case, then what you can do is you plot your point just somewhere there in the first quadrant where it should be. And if our line is going to be parallel, we can now see that it is passing through the x coordinate of a negative 45. So that is our x value. If we wanted our line to be perpendicular to this one, we've already said that it's going to be something horizontal. And if our line is going to be horizontal, it's going to look like this. it's now going to be a y equals, and the y coordinate here is 19, or you can use the picture. So y equals 19. Last thing that we want to talk about here is solving equations by clearing fractions. Whenever you have fractions, please, I wish and hope for you, please do not try to add and subtract those fractions. We can make our problem easier by simply multiplying through by the least common denominator. Now, I've made this one pretty simple, and we can just multiply this entire equation by 7. We're going to distribute that 7 all the way across. That's going to give us a negative 3x, because it now cancels, minus 14. Going to the other side, I can even take this 7 and automatically distribute it into this x minus 10, 7x minus 70, and then plus 14. Now this problem is going to be so much easier for us to do. We can start combining our like terms. I like to clean up the other side really quick first. So this is going to give us a 7x, because again, I don't have a calculator, so I like to do this first. So this is going to give me a negative 56 here. Think it in my head. Now I'm going to move my variables over to the right. So I'm going to have a 10x, add that 56 to both sides. That's going to give me a 42. So I would have 42 over 10. I don't need to convert that to a decimal, but I would want to think, oh, they do both easily divide by 2, and I can write my answer as 21 over 5. Again, we're not using a calculator, so there's no need to think about what the decimal would be in this case. Okay, so that's all that we've got. We'll do some more practice with this in class, but if you've got any questions, just make sure to jot those down.